Okay, so now here is approximation. We're going to use tangent lines to approximate different things. Now, I'm going to give you a couple of different examples. These questions can be worded several different ways. Let's just start off by saying f of x is equal to x squared minus 1. And we're going to pick the point at f of 2. And we're going to set up a tangent line to predict what f of 2.1 would be. All right, now, this is a basic example. I know, any one of us could pick in 2.1, plug it in here, and get an exact answer. That's fine. That's not what we're trying to do here, though. We're going to use a tangent line to make this prediction. So, the first thing we need, we got to construct the tangent line. So to construct a tangent line, we need a point and a slope. Well, f of 2 is 2 squared minus 1, so f of 2 is 3. All right, f of 2 is 3. So we've got a point here for the tangent line. Now we need the slope for the tangent line. Slope is going to be the derivative. So f prime of x is 2x. So f prime of 2 is 2 times 2, which is 4. All right, so I've got a line. My line has a slope of 4 and the point 2, 3. So let's go into point slope form. Y minus y sub 1 equals m times x minus x sub 1. All right, well, y minus, all right, my point is 3. M, all right, my m is 4. And then it's x minus x sub 1 is 2. Okay, so we get that y is going to equal to 4 times x minus 2 and then plus 3. Okay, so from here, this is my line. It's not quite in slope-intercept form, but it's pretty close. But I'm going to use this to predict f of 2.1. So I get that y is equal to 4 times 2.1 minus 2 plus 3. So 4 times, all right, this would be 0.1 plus 3. So we get 4 times 0.1 is 0.4. Plus 3 is 3.4. So my estimate for f of 2.1 is 3.4. Now, another thing we can look into is this an over approximation or is this an under approximation? Well, I'm going to draw 2 examples here. This is my first example. Here's a tangent line. That's tangent line 1. And this is tangent line 2. Okay, now I'm going to draw another example. This is tangent 1. And this is tangent 2. Now, looking at this is concave down. And notice tangent lines on concave down are always above the graph, except for at the point where they're tangent. This is concave up. Tangent lines on a line that's concave up are always below the curve, whether it's concave up and decreasing or concave up and increasing. The tangent line's below the graph. Here, this is concave down and increasing right here. This is concave down and decreasing here. it doesn't matter whether it's increasing or decreasing. The concavity is all that matters as far as it being an over approximation or an under approximation. So let's determine if this is an over approximation or an under approximation. Well, for concavity, we need the second derivative. So f double prime of x is 2, which is positive. So we are concave up. So since we're concave up, our tangent line will be below. So it will actually be an under approximation. Now let's just check this out and see what it is, because we can physically figure this point out. So what is f of 2.1? Well, 2.1 squared is 4.41. And if we take 4.41 and subtract 1 from it, we get 3.41. So see, 3.41 is greater than 3.4, so that does tell us that this is correct. This would be an under approximation for that. But see how it is really close. Just a second, I'm going to do another video. It's going to show another application to approximation, and then this is very similar to the one that's on the study guide that I just gave you. So we'll look at a few more things with this. We can use this type of approximation to find zeros and so forth, but I want to give you just one more example where we could not actually physically figure out what the point is.